Hello, dear students, and we are start our lecture by new discipline. New discipline is called Technological Foundations of Mechanical Engineering. And now we start theme 1, Basic Concepts and Definitions. The plan of our lecture. First question. Classification of products. Second question, or item 2, production and technological processes as a machine building factory. Item 3, parts of the technological process. Please write down to your notes the theme of our lecture and the plan of our lecture. And we continue, and we start item 1.1, classification of products. So, a product is an item of production subjects to manufacture at the factory. There are following types of products: parts, assembly units, complexes, and sets. And you can see the scheme of the classifications of products. Write down to your notes this scheme, these types of products. So once more again. The types of products, it's parts, assembly units, complexes, and sets. Depending on the final stage of this production, products can be not only manufactured or repaired machines, but also complete machine elements and individual parts. For example, for an automobile factory, the product is a car. For a motor building factory, it is an engine. And for a piston factory, it is a piston. Products, depending on the presence or absence of their components, are divided into two groups. First group, A. Not specified, not have components or parts. It's first group of products. It's not specified. And second group, B, specified, consisting of two or more components or parts. It can be assembly units, complexes, and sets. So parts, it's only not specified products. And assembly units, complexes, and sets, it's specified. they are consisting of two or more components. Write down to your notes this scheme of classifications of products. You have the time, 1 minute, please write down to your notes. And now we can show the next slide. A part. What is a part? A part is a product made of homogeneous material without the use of assembly operations. An assembly unit is a product, the components of which are to be connected to each other at the manufacturing plant by assembly operations, screwing, welding, etc. Write down to your notes what is a part, what is assembly units, and the next type of products is a complex. A complex is two or more specific products that are not connected at the manufacturing plant by assembly operations, but are intended to perform interrelated operational functions. For example, an automatic workshop, drilling rig. A set is a set of products that have a common operational purpose of an auxiliary nature, or, for example, a set of tools, a set of spare parts. So, please write down to your notes what is a part, what is the assembly unit, what is a complex, and what is a set. One more time, a set is a set of products that have a common operational purpose of an auxiliary nature. For example, a set of tools, a set of spare parts. And now we start item 1.2 of our lecture. It's production and technological processes at the machine building factory. Production and technological processes at the machine building factory. At the machine building or car repair factory, various processes are performed related to the manufacture or repair of products. The totality of interrelated actions of people and tools of production required at a given factory for a manufacture or repair of a product is called the production process. or manufacturing process. So the production process includes not only the main processes associated with the transformation of initial materials to obtain finished products, but also auxiliary ones, such as the production of tools, fixtures, equipment repair, as well as service processes, intra-factory transportation of materials and parts, warehouse operations, control, etc. To enable the production of products. Please write down to your notes what is the production process. I repeat one more time. The production process includes not only the main processes associated with the transformation of initial materials to obtain finished products, but also auxiliary ones, such as the productions of tools, fixtures, equipment repair, as well as service processes, intra-factory transportation of materials and parts, warehouse operations, control, etc., to enable the production of products. Write down to know this definition. It was the production process. The next type of process is a technological process. And a technological process is a part of the production process. The difference between technological process and production process is that the technological process is a part of the production process that contains actions to change and further determine the state of the subject of production. Consequently, when performing the technological process, a change in the shape, dimensions, properties of the material of semi-finished product is achieved in order to obtain a product in accordance with the specific technical requirements. There are technological processes of machining, heat treatment, assembly, etc. The examples of technological processes: it's machining, heat treatment, assembly, etc. So write down to your notes what's the difference between a technological process and production process. And before we start the next item of our lecture, I want to show you some videos. We clean our screen, and now I want to show you the videos about production and technological processes. First video, the manufacturing process inside mechanical fabrication factory. It's machining, milling machine. Welding, again milling, milling of gear weld. Cutting on lathe machine. Cutting on the lathe machine. It's all what you can see, it's all the technological processes. It's not our type of technological process. Drilling. It was drilling. Next type of technological process. Tracking. Was ball for bearings. As a type of cutting on the lathe machine. And it all was the technological processes. Next video is characterize the manufacturing process. Manufacturing process. Manufacturing processes. And manufacturing process consists from cut wire and make the wire strengths, cut wire and make the wires waved, frame welding, automatic welding, combination welding, CO2 cooler welding, full inspection, and surface treatment. Automatic strength wire machine. Automatic wave wire machine. Automatic crossing welding machine. Edge cutting. Semi-automatic frame welding. Combination welding for a shell. Cooler welding. Full inspection for removing edges. Tube manufacturing process flow. It's tube cutting, tube notching, insert bolt, tapping, full inspection of joint, full inspection of tapping, and surface treatment. Tube cutting, tube notching, bolt insert, auto taping, full inspection of joint, of joining. Chrome plating processing. The parts of chrome plating processing. Pre-processing, chroming, and post-processing. And the last type of technological process in its inspection and packing. Powder coating process. Pre-processing, powder coating, and inspection and packing. Automatic chrome plating line. Plating line. Automatic chrome plating line. Pre-processing, oil and rust cleaning, wash. Chroming, handling production line, acid peeling, electroplating, automatic chrome plating line, tube. Separate wire shell. Washing, drying, inspection, and packing post-processing. Powder coating, drying, spraying. Inspection and packing. Packaging. Packaging, tube checking, taping check, tube connection checking, lens consistent checking, tube converting, inspection of tube, packing tubes, assembly instruction, accessories, and double check. And the finish is sailing. Tube check, taping check, connecting check, lens consistent checking, tube covering, shelf check, assembly instruction and accessories. Auto selling. And distribution. It was a manufacturing process. Next video, the technological process.
Welcome to this new time-lapse video. Today, we are going to talk about the technological process, which is the set of steps that we have to follow in order to find a solution about satisfying
First step of technological process.
Need. Analyze the need or problem and the possible restrictions. 2. Search information. Study similar cases and their possible solutions. 3. Ideas. Propose one or several solutions. Draw sketches. Choose the best one. Draw a plan with all the dimensions. 4. Plan the work. This is a list of things to do. Write the material sheet. Create a process sheet. And elaborate a budget. Number 5. Constructions. Here, you must follow the instructions written in the process sheet and take notes of any problem or modification that you can find. 6. Check. Verify that everything works as you want. Evaluate yourself. Return to the idea and check all the steps. If it doesn't work properly,
And the last video that I want to show to you, it's video number 4.
In this video, we are going to explain the 6 steps of the technological design process.
Steps of technological design
When a
process.
human being has a need or a problem, they try to find a solution. The technological design process permits us to make an object that provides a solution to said problem. To achieve this, we need to perform a series of 6 steps that are as follows. First, recognize our need. Second, design a solution. Third, plan its construction. Fourth, construct the object that we have designed. Fifth, verify that the entire process has been completed correctly. Sixth, and finally, collect everything in a report. So, let's talk a little bit about each of the steps. The first step is recognize the need. Recognizing the need is the starting point to subsequently design the object. It is very important to collect in detail the specific needs that we want to resolve. We will not be able to carry out an accurate design if we do not know which of the characteristics are needed to complete our product. For example, if we want to construct an object that flies, the capability of flying cannot be the only requirement for our solution. Why? Because all of these inventions can fly. However, it is not the same to design a helicopter that rescues people than it is to design a fighter jet. The specific requirements for each example makes the final design very different. And we should know that each of the details or necessary requirements so that our object successfully solves our need. The second step is design the solution. Here, what we are going to need to do is look up information about objects or designs that already exist and that solve similar problems to our own problem. We will not always find a solution that is perfectly adapted to our problem, but we can take an idea that already exists and adapt it to our own needs. Think of the engineers that developed the first rocket capable of carrying humans into space. To be the first means that nobody before had designed a rocket, but they found objects that serve as inspiration for their design. The design has to adapt itself to our knowledge, to our tools, and to our materials, but also to the time that we have for the construction, to the budget that we have assigned, and including our own likes, because the aesthetic also forms a part of the design. If we work as a team, we can carry out a brainstorming session and later vote on those ideas that seem better. When we find a design that suits us, we have to describe it in the most precise way possible. And in technology, in order to detail an object, we use plans. We have to create plans of the object as a whole and also plans for each of its individual pieces. The plans should be correctly finalized and preferably to scale. The third step is the planning. Here, we need to make a detailed list of all the tools we are going to use, and another list with the materials and its price, to know the real cost of the project. A project would also take into account additional costs, for example, labor, renting, machinery, and licenses. Another important part of the planning is detailing in correct order the tasks that will be completed and assign each task a determined time as well as a person responsible for it. This part of the planning process is completed with PERT diagrams. But in the first steps of the technological process, we can use a similar table like this. The fourth step is the construction. After the design and planning phase, the moment of beginning construction arrives. During construction, all of the plans made in the design and previous planning phase will be followed at all times. If we consider it necessary to make any variation, we will take note of it in order to reflect on it afterwards in the report. And lastly, during construction, all of the safety rules will be mandatorily respected, and it is recommended to take photographs of each step in order to include them in the report. The fifth step is the verification. Verification is important to assure us that the entire process has been developed correctly. A part of the verification is done side by side with the construction, evaluating each piece that is fabricated in each step of the assembly. In this way, we can detect and correct errors before it is too late. The last part of the verification is done at the end of construction. And what are we checking? Well, we're checking that the operation is correct, the structural resistance of the object, and the success of the overall design. In this verification process, we can also include proposals of improvements for our product. The last of the steps is to write a report. The report is a written document in which all the information generated during the previous steps is collected. The objective of the report is to communicate with other people the exact process in order to construct the object that we have designed. This document will have the following parts: a cover page, an index, a description of the need that we want to resolve, a description of the technological object, plans for the object, a list of tools, a list of materials and proposal, a construction plan, photos of the construction, and ideas of improvement. These steps of the technological process, although they can seem complicated, really are very intuitive. A typical example of this theme is how to prepare a birthday cake.
So it was the technological process of design of different items, design of different objects. And now we start item 1.3 of our lecture, parts of the technological processes. So the completed part of the technological process performed at one workplace is called a technological operation. Please write down to your note, what is the technological operation? Technological operation is the completed part of the technological process performed at one workplace is called a technological operation. The technological operation is the basis of the production planning of the technological process. The technological operation is used to calculate the labor intensity of the technological process, calculate the required number of workers by qualifications, etc. The technological operation contains the following elements. Setup. Setup is a part of the operation performed with the unchanged fixing of the workpiece being processed or the assembled unit. For example, when performing the operation of centering the ends of a shaft blank on the lathe, two setups are required since first one end is centered and then the other. The same operation can be performed in one setup on a double-sided centering machine, which allows simultaneous centering of both ends. The operation is divided into technological and auxiliary transitions. Technological transition is a completed part of a technological operation characterized by the constancy of the tool used and the surface formed by processing or mating during assembly and the constancy of the operation mode. For example, sequential tuning with a cutter first of one stage of the shaft and then the other will consist of two technological transitions. If you turn these steps simultaneously, like in figure 1.1. With two cutters, then this will be turning in one transition. The processing of the same workpiece surface in the roughing and then finishing mode will consist of two technological transitions, since the cutting mode changes. Auxiliary transition is a completed part of a technological operation consisting of human or equipment actions that are not accompanied by a change in the shape, size, and surface roughness, but necessary to perform a technological transition. Examples of auxiliary transitions are setting the workpiece before machining, rotating the cutting head, and so on. One more time, examples of auxiliary transitions are setting the workpiece before machining, rotating the cutting head, and so on. So write down to your notes this scheme with technological operation. Its setup. Technological operation can be divided by setup, transition, and position. And transition can be divided by technological transition, auxiliary move, and working move. Write down to your notes this scheme. Its types of technological operations. The working move and auxiliary move. The working move is a completed part of the technological transition in the form of one-time movement of the tool relative to the workpiece, accompanied by a change in the shape, size, surface roughness, or properties of the workpiece. For each working move, one layer of material of a given thickness is removed with the same processing mode. Auxiliary move. A completed part of the technological transition in the form of a one-time movement of the tool relative to the workpiece, not accompanied by a change in the shape, size, surface roughness, or properties of the workpiece, but necessary to complete the work move. For example, the auxiliary move is to move the less support to its home position after tuning. So write down to your notes what is the working move and what is the auxiliary move. What is the working move and what is the auxiliary move? When performing certain technological operations, the installed and fixed workpiece or the assembly to be assembled must occupy a number of successive positions in relation to the working bodies of the equipment using rotary or moving devices. That is, they must occupy different positions. So, position. Write down to your notes what is position. Position, a fixed position occupied by a fixed workpiece or an assembly being assembled together with a fixture relative to a tool or a fixed piece of equipment to perform a certain part of an operation. For example, in figure 1.2 shows the milling of surfaces 1 and 2 in two positions. The workpiece is fixed on the rotary part 3 of the device 4. After processing the surface 1, first position, the workpiece without unfastening is turned 150 degrees with the help of the rotary part of the device, fixed with the fastener 5 and milled the surface to second position. When processing workpieces on a turned lathe, each of the successive position of the turned is considered to put a new tool into action. The use of multi-position machining increases productivity by reducing the time spent setting up and clamping workpieces or changing cutting tools. So it was the last slide of our lecture. On your screen, you can see check questions for this first lecture. Use these questions when you will be prepared for the next lecture. And I can ask you about our lecture number 1. List the types of products. How does the production process differ from the technological process? What is the technological operation? List the components of a technological operation. What is the difference between working and auxiliary moves? So you need to know the answers on all these questions. And now our lecture is finished. Be safe. Goodbye. See you on the next lecture. Goodbye.